off into some piece of memory that was allocated out of non-page pool, which isn't even backed by a loaded device driver. So in that particular case, you look at the system and you're looking at this piece of memory and it's not backed by any specific DLL, so who did it? How do I discover what code was responsible for that? How does the system behave if somebody else comes along and tries to patch the same routine? What's the order of the calls that happen? What happens when somebody removes themselves from that call chain? It becomes very unpredictable and unreliable in that circumstance, not to mention that there's really no inventory of what's running anymore, which is really a situation that is more like malware, a situation created by malware versus a situation where you've got legitimate software running that's easily discoverable by the end user. So that was another problem that we indeed wanted to see go away.
Absolutely. But I mean, just to be clear, on 32-bit Vista, you could still, unfortunately, install software that runs in the kernel that you don't know is running, that the system doesn't know is running. Are we saying that we would, because it doesn't have to be signed, right? Or let's just talk about, because I'm sort of a paranoid user, and one of my worst fears has always been like rootkits.
Yep.
And stuff's going on, you have no way of detecting it. You can't detect it with Process Manager. You could write code and try to detect it, but that's not easy for most people. So that really freaks me out. I mean, stuff running that I can't know that's running, the system doesn't know that's running, and that could be doing God knows what.
Yeah, it can do anything, basically.
So let's talk. I mean, we have addressed that a little bit. I mean, I'm not trying to take away this whole. The point is it just signing code that disables that to happen, or what other kind of innovations are going on?
Yeah. So like I said before, signing code is really just to start. That's really to help identify the software and prove that the software hasn't been modified since it was shipped by the vendor.
Okay.
So the role of PatchGuard is really to prevent unauthorized modifications of the kernel image itself, and then critical data structures that dramatically influence the kernel, like the interrupt dispatch table is a good one. So PatchGuard is in the business of enforcing that very, very straightforward policy that says nobody can play with these resources.
Okay.
Beyond that, we're looking at a number of other improvements down the road. So one is around virtualization features. So we've got a team at Microsoft working on a hypervisor, and this is an area where we thought that changes like PatchGuard are goodness today. So PatchGuard is in the kernel today. It's running, unfortunately, it's running in the same security domain that it's protecting today. So a malicious guy might be able to find a way to turn it off, for example. And we think about those cases from time to time. And whenever somebody reports such a case, we generally respond and update PatchGuard. But because it's in the same security domain, it's going to be subject to those attacks periodically. If we move to a hypervisor-based world, this gives us the opportunity to actually move that implementation to the hypervisor. So the PatchGuard implementation could be in a hypervisor, which means that it's no longer in the same security domain that it's protecting. So you could have a case, for example, where you've got a bunch of code loaded into memory, and that could be the kernel and other images, and you can now say that with a hypervisor that the pages of memory that back that code can't be modified. Whereas today you have a situation whereby the page table entry attributes that define whether a page is readable, writable, executable, etc., those attributes can be modified from inside the kernel. So if we had that logic, if you will, moved into the hypervisor can now use the CPU to say that, well, these pages are read-only for real. And if somebody inside the kernel that's being hosted inside the guest partition, they try and modify those page table entry attributes, it'll just fail. So that's an area where we're looking very hard at that in terms of what does it mean for patch guard, and what does it mean for other code that's running in the kernel. The other question that is related to that is sort of covered by the NX technology to some degree. So the NX and DEP technology says that in order to execute code, it has to be in a page that's marked as executable. If it isn't, it just faults. So there are some things we can do down the road from Vista to leverage that even further.
Cool.